All right, let's get started with today's topic. Okay, so let's get started today. We're going to talk about configuring and troubleshooting DNS today. Okay, so do you guys remember we spoke about DNS in 5RCW? What's DNS, guys? Domain name system. Okay, so DNS, and what does it do? Okay, so what you're saying is just it translates between IP addresses to names, right? And what about you, Artem? What do you think DNS does? Okay, so what you're saying, it's also part of the Active Directory, isn't it? Okay, so basically DNS, main function of DNS is to, instead of saying translate, we're going to say resolve. Okay, resolve names to IP addresses. Okay, names to IP addresses, that's the forward direction. That's what's called a forward lookup. Okay, but it also does what you said, Steve. It does resolve IP addresses to name, and that's what's called a reverse lookup. Okay, so that's number one, what it does, resolves names to IP addresses, and secondly, it resolves IP addresses to names, and thirdly, if it's an Active Directory integrated domain, DNS server, like you said, Artem, it actually provides the service records so that your computers can find those Active Directory computers in order to use them. For example, when you guys came into the room today and you turned on your computers and you wanted to log in, how did your computers know which computer to send the authentication information to? Okay, normally a domain controller is required, isn't it? But which domain controller is available now? Which domain controller should these computers be sending their information to? Well, it doesn't know, except that when you turn on the computer, these computers got their IP addresses from a DHCP server, and they also got a DNS settings from DHCP server. And when this your computers, which are part of the domain, asked the DNS server, who is my LDAP server? Who is my Kerberos server? That DNS, using its Active Directory integrated DNS server and using its service records, told your computers who to send that authentication information to. Okay, so DNS does quite an important job in our network. Okay, every network has a DNS server or has a DNS server that it uses. Especially if you've got Active Directory. If you've never heard me say, guys, no DNS, no Active Directory. Okay, every time you guys have a problem joining a computer to a domain or something like that, I always configure what's it do a troubleshooting called confirming the basics. I confirm that you have an IP address. I confirm that IP address is correct in relation to the domain controller. I confirm that you're on the same network. I confirm your DNS settings are correct, and then I confirm your domain name is correct. And most of the time, those few steps troubleshoots most of the problems that students get, okay, from joining the domain. So today, what we're going to do is have a look at configuring the DNS roles. We're going to configure a DNS zone and understand what the zone is. Talk about zone transfers and what does that mean, as well as looking at some troubleshooting methods for troubleshooting the DNS service, okay? So first of all, let's look at the different components of the DNS solution. All right, guys. So if you look at this diagram, you have three types of components, okay? You have what's called DNS resolvers, okay? That's any computer that needs to resolve a name, okay? For example, my computer in front of me, if I type a URL into the, into the address bar, it will need to resolve that into an IP address before your computer can actually go to that website. Okay, so computers use IP addresses to communicate, but as humans, we love to use names, and we remember names a lot better than IP addresses. So we type our names, the URLs of our favorite website, like google.com, into our computer, and that computer is a resolver. it will use its DNS settings to actually query the DNS servers. Okay, you might have multiple DNS servers, but let's say we're using this one. We'll query this DNS server. That DNS server has what's called a zone file with resource records. Resource records are those entries in a zone file which has the different records and their IP addresses and so forth. So, for example, if this is actually TAFE-SA's DNS server, we will query TAFE-SA with what is www.google.com. But the TAFE-SA DNS server would not know about the Google servers, would they? They're not responsible for the Google domain. They're responsible for the tafesa.edu.au domain. So therefore, what they have to do is either they have to forward it to another DNS server, or they actually use their root hints, which is basically some settings in the DNS to actually go to the root servers in the world. And these root servers are represented by the dot. Okay? And basically we'll ask the question of the root servers, do you know www.google.com? The root server will say, I don't know specifically the www.google.com, but I do know the top level domain name, .com. So go ask the .com top level domain name DNS server. So our DNS server will then go to the .com top level domain DNS server and ask, do you know Google, www.google.com? It will say, I don't know www.google.com, but ask the Google DNS server. And then when we ask the Google DNS server, the Google DNS server will reply to us, www.google.com is actually an alias for server123.google.com, and give us the IP address. And the DNS server will then put an entry in its cache and then actually send the results or the answer back to the resolvers. Okay, so the resolvers are our devices or computers that needs something to be resolved. The DNS server is the service that it asks, and the DNS server can reuse its own resource records to answer the question, or can use a forwarder or the root servers going through the DNS system and finding the answer. So that's why if you had a website and you wanted to register a domain, you actually have to go to a company and register the domain. You have to go to somewhere like GoDaddy.com or Melbourne IT or something like that, because you have to fit in to the DNS system. If you don't register your domain, no one will ever be able to find you through these root servers and top-level domain servers. And that's why you register, in order so you can be found by people on the internet. You get me, guys? All right, let's keep on going. So what are DNS queries? Okay, DNS queries is a question. Okay, question is, who is www.google.com? That's a query. Okay, let me give you an example of a query right now. So I'm going to start my command prompt, and at the command prompt I'm going to type in NSLOOKUP. Okay, NSLOOKUP means name server lookup. Okay, it's a way of asking the name server a query or question. So who is www.google. Oops, way too many O's. Google.com. And basically what's happening now is that it's actually going to the DNS server it's been configured to use, which happens to be this server, the tafesa.edu DNS server. And then it gave us this answer to say that www.google.com has this IP address. So a query is a question, and we ask the DNS a question, and if the DNS has been configured correctly and has all the elements it needs, it will be able to give us the answer to a query. So we can do a query by using the NSLOOKUP, but in reality, every time we type a URL into our address bar of our browser, we're doing the same thing behind the scenes. Okay. So a query is a request for name resolution and is directed to the DNS server. A query can be recursive or iterative. A DNS client and DNS servers can initiate these queries. And we'll talk about exactly how it works in a second. A DNS server are authoritative or non-authoritative for a namespace. What does that mean? It means authoritative means I know for sure because I'm in charge of this. Non-authoritative is this is the answer, but I'm not the person in charge. Okay, so it's a bit like you were there, you saw something, so you're eyewitness. Whereas if you say my friend said he saw this thing happen. You're just really passing on something you've heard, haven't you? So that, if you like to think of it, if you were there, you saw it, you authoritatively know. But if you heard about it, but you didn't see it, and it's hearsay, it's non-authoritative. You guys get me? Okay. So for example, the TAFE-SA DNS server, you ask a question about any TAFE-SA computer, it can give you a DNS answer to your DNS queries, and it will be authoritative because it knows for sure, because it's in charge. But if you ask our TAFE-SA DNS server about google.com, it's not the DNS server for google.com. It really doesn't know much about google.com except for what it's going to learn from the DNS system through the root servers and so forth. So therefore, when it gives you the answer, that is non-authoritative. You get me, guys? All right? So it's heard it from someone else. So DNS servers are authoritative or non-authoritative for namespace. So an authoritative DNS server for namespace will do the following. It will return you the IP address of the server you asked about. Okay? Or it will give you an authoritative no, it does not exist. Okay? You could ask a DNS anything, but if it doesn't exist, you can't answer, you can. So if it's an authoritative server, it will just say no, that doesn't exist. A non-authoritative DNS server will do the following. It will check its cache. Okay, a cache, if you don't know what that means, it's a temporary storage. So for example, if I've just asked our DNS server what is google.com, it's actually going to store the answer in its DNS cache when it finds out. So if a second person then asks again, instead of asking again, going through the whole process of the root servers and such on the internet, it's going to just look in its cache and give you the answer that it has in its cache. Okay, so instead of doing that whole thing again. If it's not in its cache, then it will use its forwarders. So if it's DNS, if it doesn't connect to the internet directly or it's configured with a forwarder, it will forward the request to another DNS server. Okay, it's a bit like the handball. I don't want to do the job, let someone else do it, next person do it. Okay, you probably find this in a situation where you've got a business and you've connected to an ISP, you have a DNS server, but you don't want your DNS server to be doing all the work. Or you believe that you'll probably get more cached information from your ISP's DNS server. So therefore, you might actually configure your DNS server to forward all requests that it doesn't know about, if it's not authoritative for it, to the ISP's DNS server. You get me, guys? So then the DNS server for your ISP will do all the work, or it uses cache. And then finally, if it's not configured as a forwarder and the information is not in its cache, it will use the root hints like I described earlier. Okay, so let's have a look at how a root hints work. Okay, sort of described it earlier, but let's go through again. So in this case, it's Microsoft.com. Okay, that's what we're looking for. So at my client, my computer, I've typed in www.microsoft.com. Okay, and it's actually forwarding. It actually uses its DNS settings to go ask the DNS server. In this case, ask the DNS server, and in this case, the DNS server doesn't have any forwarders, and it goes through the root servers. It will ask the question of the root servers, do you know www.microsoft.com? And the root server will say, no, I don't know that, but I do know who the .com top level domain DNS server is. Go ask him or her. So then it will go to the .com server. Do you know Microsoft www.microsoft.com? It will say, I don't know that specific query, can't answer that specific query, but I do know the Microsoft DNS server. Go ask the Microsoft DNS server. And then you'll go ask the Microsoft DNS server, and the Microsoft DNS server will say, hey, www.microsoft.com is actually an alias for server 123.microsoft.com, and here's its IP address. And it will return it to your DNS server. The DNS server will put it in its cache, and it will also return the answer to your client. Okay? So that's how the root servers are used. Yeah, it's basically going to one place, which gets you close to the next place, and next place. So that's how the DNS system works, okay? So if we look at this, this is exactly outlining what kind of queries they are. Okay, so this is DNS client. In this case, I'm asking about mail1.contoso.com. It's going to be a recursive query to my local DNS server. My local DNS server is configured with a forwarder. So instead of doing the work itself, it's going to be forwarding it to the forwarder. Again, it's a recursive query. But in this case, the forwarder doesn't know either because it's not authoritative for, not authoritative for the contoso.com. So it's going to use iterative queries and ask the root server. So that's a dot. It's represented by a dot. So all DNS names like mail1.contoso.com has a dot at the end, even if you don't type it in. It's implied, okay? It's hierarchical. Starts at the dot, which is a root, then goes to the next biggest thing, .com, then contoso, okay? So in this case, the forwarder will do an iterative query to the root servers and ask, do you know mail1.contoso.com? The root server will say, no, I don't. Go ask the .com top level domain DNS server. So we'll go there. And it'll ask the same question. Do you know mail1.contoso.com? The .com DNS server will say, no, I don't. Go ask the contoso.com DNS server. And then when we ask the contoso.com DNS server, it will say, hey, mail1 is really an alias for server 123 at .contoso.com. Its IP address is 131.107.0.11 and sends the authoritative response. So this is authoritative because this guy is responsible for that domain. Okay. To the forwarder returns it to the local DNS. The local DNS puts a copy on its cache and gives it back to the client. Okay. So the next thing is we talked about caching the results. So here's an example of how the cache works. Client 1 asks the question, where's server 1? It goes through the whole process and gets that as the IP address of server 1. That is stored in a DNS server cache. Okay, so that's the name, that's the IP address, and that's the TTL. Okay. Now, second time, the client 2 now asks the same question, exactly the same question. Where's server 1? Instead of actually going through the whole process again, he actually just checks his cache and realizes server1.contoso.com is this, so he'll give it straight back without having to go through the root servers again. So this TTL stands for time to live. Okay, so with DNS, there's always a chance that the entry or the address for that server 1 can change. I've done that many times. I've had one server take over the responsibility of another server, so I had to change the IP address for a particular entry or record. But the problem is, if this is in the cache of the DNS server, it doesn't matter if it actually has changed. It will still be in the cache. So the second person, the third person, the sixth person who asked the same question might get this wrong, this answer. But if it's changed, that might be wrong. So what's worse than not having the answer is having the wrong answer. So therefore, in order to make sure that this is not wrong forever, there's a TTL or time to live. So once this time to live is actually reached, it will be flushed or aged out of the system. Okay, so this will be removed from the cache, and then the DNS server will go through the whole process again and get the new IP address. Okay, guys, is that making sense? Yeah, it's all right. All right. Here's another term. What is DNS round robin? Okay, first of all, you guys might have heard the term round robin in sporting context. Have you heard of that term? Like when you have a World Cup qualifier, World Cup. Yeah, you guys know about the Soccer World Cup? Yeah, you do? No. All right, you guys are not sporting people, but basically, forget about that. Round robin means that you each have a turn. So in a World Cup group stage, the people you play everyone in your group once. You go through all of them. Okay. In this case, round robin means that there's free web service for this www.contoso.com. Okay, so what does that mean? That means all three of them have this website on them. So for a large company like Google, for Facebook, eBay, one service is just not going to be enough for everyone that wants to use it. So therefore, this round robin load balancing is a way of actually balancing the requests so that all three of them, in this case, takes a turn responding to the requests. So how does it work? So basically, so these are the free web servers, and they have these IP addresses, and these are the entries in the DNS. Okay. So when someone at this computer types in www.contoso.com into their browser, it will go to the DNS. It eventually gets to the Contoso DNS, and the Contoso DNS will look at its resource records and give this guy the IP addresses, all three of them. You know what this guy's going to do? This guy's going to use the first one off the list and go to 11 and get the website. Okay, so this server's had a chance to serve up the information. But another user comes in and types the same thing in. Okay, but in this case, the DNS server here at Contoso is going to return not 11 as the top one, but 120. You notice that sort of the 11 went to the bottom, didn't it? So now this guy is going to go to 120 to get the website instead. And the next one, it will be 133. It will go back to 111, 120, 133, and it will go on like that. So each one is getting a turn in the rotation. You're going to ask a question, Artem? Yeah, clustering also works as load balancing, but in this case, this is just specifically to do with DNS. Okay, so in this case, all the servers are getting a turn serving up information to the client. Yeah, so it's not like one's overwhelmed with a million requests and the other two are doing nothing. They're all taking a turn. Okay, but this is not load balancing based on traffic or amount of data that's been transferred. It's based on sessions. Okay, what does that mean? It means that you could have the first person who went to 11 could have just wanted a website and it will be very small traffic. Okay, but the second one might have gone to 120, which wanted to download a file that might be 100 megs. So that's a lot bigger traffic than the 1 meg web page. The third one might have been wanting to upload a 10 gig file. That's even more traffic. So basically, it's not, this load balancing doesn't balance the amount of traffic. Okay, but what it does is balance the number of sessions. Okay, so over the long run, it should even out, but not in one situation, it might be very heavy. Another situation might be very light. Okay, so let's look at what considerations to think about when we're deploying DNS server. Okay, so I'll give you an example. So this picture might represent 3 different networks: subnet 1, 2, and 3. I'll tell you now, at TAFE, here in our classrooms, we have a student network. We also might have a lecturer or administration network for my office computer. And we also have a server network. So the reason why we separate the student and the lecturer computers on different networks is for security reasons. Okay, we know that students can bring their own computers, their own laptops, and connect to these classrooms. So we wouldn't want to actually allow this traffic from this network, the student network, all the way to the lecturer network, where we might have very sensitive information like your grades, your personal information, our intranet, and so forth, our tests. So we might have differing restrictions. So in this case, we might put a DNS server on the server network for the lecturers, so they can just go through here and use that DNS server. But for the students, we might keep it separate for security reasons again. We might have a DNS server for the student network, which then forwards to the lecturer network. And that way, there's only one computer that's talking to this server network rather than anyone. But this is some considerations of where to place DNS, and that's just one example. If you just had a simple local area network and had only one subnet, it doesn't matter. But if you had a more complicated network such as TFSA with the different security zones and different networks and even different sites, you may need to place your DNS server strategically. All right, let's look at what are DNS records. Okay, so here's some examples of DNS records, but let's actually switch over to my virtual machine and I can actually show you some of these DNS records in real life on a server. All right, so I've got my virtual machine running here, which is basically the same virtual machine that you guys would use later on. All right, so for example, this is a Server 2016 domain controller. So it has the DNS server installed. And if we look at the forward lookup zone, we have the w2k16.ad.local domain. This is an Active Directory integrated domain, okay? So first of all, you have these things called A records. A records are basically records that represent individual hosts or computers. Okay, this is IPv4 A record. If this was IPv6, it would be called a quad A records, 4 A's, okay? And they represent individual computers. For example, there's server 1, server 2, and my Windows 10 client. We also have these things which are called CNAMEs or aliases. In this case, www is an alias or CNAME for server2.w2k16ad.local. An alias is like a nickname, okay? It's another name for this particular server. We also have these MX records. MX stands for Mail Exchanger, okay? So you know how we send an email, we always go, you know, for example, my email address on the board is alex.zhao@tafesa.edu.au, isn't it? Nowhere in that email address does it say which server is the mail server. It's just user@domain, isn't it? So how does a one mail server find another mail server's IP address? It actually just requests or queries the mail exchanger of that particular domain. And in this case, looks like server 2 is the mail exchanger as well. Okay. So let me just quickly show you again a query. So if we actually did the NS lookup www.w2k6ad.local, so we're really asking who is this w2k16ad.local, and when we get a reply, it's going to say, hey, www is actually a alias. Okay, that's what it's saying. It's alias for server2.w2k16ad.local, which has this IP address. Okay, you get how that worked? All right. There's also what's called a NS record. Okay, NS stands for name server. Who is the name server? So who is actually the name server for this domain? Well, the name server is server 1 in this case. That's the only one that's available. Okay, there's also a start of authority. So under whose authority is this server running? Okay, and in this case, it's server 1 and also hostmaster. Remember how I said this was Active Directory integrated DNS server? Remember how I said that there's what's called service records that's actually in this Active Directory integrators DNS that actually helps our client computers find services like the domain controller, such as the LDAP server, such as the Kerberos server. So basically, if we go into TCP/IP, for example, these are examples of server records. Here's an example of a global catalog server. Here's an example of the Kerberos server. And if you look at these are SRV or service records, and they point to, in this case, server 1. So basically, when I need to authenticate against this server, I will use one of these service records and send my username and password to the right server. All right, let's get back to our PowerPoint. So what I need you guys to know is, oh, sorry, there's one more that I didn't show you. Let's also, we said that DNS can resolve IP address to names as well, doesn't it? So let's show you a query of that. So NS look up 192.168.20.2, and you can see that here's the answer. 192.168.20.2 is resolves to server 1.w2k16ad.local. Okay, that happens in the reverse lookup. Okay, you notice that the forward lookup is just a domain name. If we look at the reverse lookup, the name's a bit weird, isn't it? Can you, if you look at these IP addresses, can you look at the name and work out what's going on here? Yeah, that's right. The name of the reverse lookup is almost like the backwards. It's backwards of the subnet ID of these IP addresses, isn't it? Plus this inner ADRA ARPA. Okay. So basically, that's what you need to remember for the test as well. Okay. So you'll have a question where you'll have all these things as reverse lookups zones for a particular IP address. And I'll ask you which one is the correct reverse lookup zone. Okay, just remember that. So inside of these reverse lookup zones, there's these things called PTR records or pointer records. And basically when I did that NS lookup for the IP address, I looked up .2, which actually pointed to server 1. Okay, and that's how it resolves the IP address to names. So for the test, the Fury test, I'll expect you to know what C names are, A records are, MX records are, and so forth, okay? So we're getting to that level where we need to know a little bit more detail, okay? So what are DNS zones? So don't forget, DNS servers are not always linked to Active Directory. So there's some DNS servers which are just purely there to resolve names to IP addresses, okay? So for example, if I have a website and I want to register a domain, I can actually register just my domain name without needing Active Directory. So when it's not Active Directory integrated, you have what's called zone files. These files are actually stored on the hard drive of your computers or DNS servers as ASCII files. In this case, you have a zone file of this Microsoft.com zone. But in here, you've got actually a subdomain called example.microsoft.com. And you need to be in the main domain here, top level, in this domain, we need to actually have a delegation for example.com. Then we have a zone file for the example.com domain. So the types of zone types, okay, so you can have a primary zone. Okay, primary zone is a read-write copy of the DNS server. Then you have a secondary zone. Secondary is really just a backup. Okay, so if you have a DNS server and it's not Active Directory integrated, you have to have a primary one, which actually can resolve names and you can make changes to the records. But when we have a secondary DNS server or secondary zone, which is a backup of the primary, it's read-only copy, which means you cannot make changes. But when you actually update the primary one, it gets transferred for a zone transfer to the secondary domain, DNS zone. Okay. Then we have these stub zones, which is where basically it's a very, very tiny little zone, just like a stub of a branch or something like that. It just contains enough resource records or enough records to actually locate the name server of that DNS or that domain. Then we have Active Directory integrated DNS. Basically, when it's Active Directory integrated DNS, instead of the information being stored as a ASCII zone file on your file system, it's actually stored as part of the Active Directory database. Okay, so if we look at this picture, we've got Active Directory integrated domain DNS. We've got these domain controllers. They're just replicating Active Directory like normal. If we have a non-Active Directory integrated DNS, we have primary DNS and secondary DNS. And when we make changes to our DNS, the normal Active Directory replication replicates the DNS as well. Okay, but if it's a zone transfer, but if it's a normal DNS, non-Active Directory integrated DNS, it's a zone transfer from the primary to the secondary. You can see this arrow is only one direction, isn't it? Okay, whereas these Active Directory integrated zones, the replication happens in both ways, in all directions. All right, so forward and reverse lookups. Okay, we spoke about this earlier, but basically a client can ask to resolve a name or a IP address. So when you do a forward direction, it's names to IP addresses. When it's a reverse lookup, it's IP addresses to names. You notice that, like I said, when we're doing forward lookup, it's based on the The zone is the domain. When we're looking at reverse, the zone is the IP address backwards, isn't it? And a stub zone. So remember we spoke about stub zone. We didn't really explain it that well. But let's just imagine that we have another company, let's say na.fabricant.com. And we always go there. Our clients are always actually requesting resources from there. So we can obviously let the DNS work normally and go to the forward it to the main DNS server up here. Then use the the root hints and so forth, and go to all the DNS until we get to the DNS server for this na.fabricant.com. That obviously if we have 100 requests a day, that's a lot of excessive traffic, isn't it? So what a stub zone means is that instead of actually going through that normal process, which we'll get there anyway, so that's not a problem, what we could do is actually create a stub zone here on our DNS server, but that will not contain any DNS records except for the name server record. So the name server record will point to this DNS server here. So instead of going through all the process, it'll go directly to this name server. That's for that domain, okay? So without a stub zone, the nynacontoso.com server must query several servers to find the server that hosts the na.fabricant.com zone. But with a stub zone, you can go directly there. So there's also what's called DNS Zone Delegation. So that's when we can have subdomains. So for example, we have contoso.com as the domain, but now we want sales.contoso.com and marketing.contoso.com. So in this contoso.com, we have to do what's called a delegation, which delegates a subdomain. So they're all related. You notice that this sales and marketing are both under contoso.com. Okay, so that's what DNS delegation allows us to get our subdomains. What is split DNS? Okay, let me just explain the situation a little bit. So, for example, in this example, we have what's called an internal network. So that's everyone on the LAN. Okay, you have your users, you have your servers, and so forth, all on the LAN. You also have some servers, like a web server, mail server, and a DNS server that needs to provide resources to the external clients, so the internet. Okay. And you notice there's an outside firewall and an inside firewall. And this thing is called the perimeter network. So that's what Microsoft calls this area. Can you guys think of any other name for this area? Okay, have you heard of any other names that's DMZ, you said? Demilitarized zone, okay? It's just like the zone between North Korea and South Korea. It's a place where you're in control of, but you don't trust the traffic from it. What does that mean? It means that potentially, if these servers need to provide a resource to outside people, it could mean that a hacker from outside could use this access to compromise the web server. And then if this web server was on the internal network, it would directly be able to compromise every other computer. But because it's still inside, there's still another firewall protecting it, it means that even if it's compromised it cannot directly access or try to attack those computers. But as far as DNS goes, it means that, hey, we've got two sets of clients. We've got external clients and internal clients. So when internal clients or clients and servers on the internal network send all their DNS queries to the Active Directory integrated DNS servers. And these Active Directory integrated DNS servers return the IP address back for those querying clients to servers and clients on the internal network, as well as the IP address of the web server if it needs to go to that web server. If these clients want to query a resource which is outside on the internet, it will still send them to the DNS servers, but in this case, these DNS servers will then be forwarded to the external DNS server, which will then use the root servers out on the internet to find the resource. Okay, name resolution requests from internal clients and servers are forwarded by the Active Directory integrated DNS to the external DNS, which then in turn sends the request to other DNS servers or through the route hints. And when it returns, the information queries come back, will go to the external DNS server, which then returns it to the internal Active Directory integrated DNS server, which then returns it to the clients. But this is an interesting part. What if we have external clients who wants to resolve or access resources on the inside? So name resolution requests from the internet entities are only replied to from the external DNS server. The external only has a list of perimeter servers that it's going to give return information about. So it's never going to tell the outside people anything about what's on the inside. So it hides your structure of your network on the inside from people on the internet. You get me, guys? So, and all requests for internal clients and servers are rejected. Okay, what is a zone transfer and how do we configure zone transfer security? So basically, we spoke about how a primary server is a read-write version of DNS. So we can make changes. And the secondary server is a backup. Okay, so they both can resolve and so forth. But what if, so the way the zone transfer is done like this, the secondary server does a SOA query for the zone, the primary answers that query, and then the secondary initiates a zone transfer, and then the zone is transferred. But the problem with this is the traditional way. The problem with this is that, you know, it has been used by attackers to actually find out a lot of information about your network. I'll ask you the question, what type of computers or devices would have an entry on your DNS server? Would you have an entry for every computer in a DNS server? Probably not. There's probably too many. But the only computers or devices you might put in there is probably something that's central, something that's important. For example, a printer, Active Directory, or some other service that's providing a shared resource, isn't it? So effectively a list of all your most important computers, their IP addresses and so forth, and even maybe the service they provide. So therefore it's being used by attackers to actually gain information about your network, to actually pretend to be the secondary server and initiate a zone transfer. It's actually been done in the past. So basically we need to secure it. So basically we can actually secure zone transfers by actually configuring a restrict zone transfers to specific servers. So therefore I'm going to list all the servers that is allowed to do a zone transfer with. Okay, so if there's an attacker has a computer and tries to initiate zone transfer, unless they are one of these servers that's in the list, that will be rejected. We can also encrypt the zone transfer traffic. So encryption means to scramble the data so no one can read it. So people can't actually then capture the information and actually read it. And we can also use Active Directory integrated zones, which means that there's no need for zone transfers. All the DNS is actually replicated with the replication of Active Directory. So here's some ways for securing your DNS zone transfers. All right, let's look at some troubleshooting techniques for DNS. So if you remember, we spoke about what's worse than not having the information is having old or outdated or wrong information. So remember how we spoke about the TTL, time to live? This indicates how long the DNS record will remain valid. Okay, for example, if I do a request yesterday, and the answer of that request is stored in the DNS cache, I don't necessarily want that answer to be there forever. So that answer is there until the time runs out, which is the time to live. And when it runs out, the records gets what's called aged out, or the act of aging occurs when records have been inserted into DNS and reaches their expiration and are removed. So that's aging. Scavenging performs DNS resource record grooming for old records in DNS. So records, again, who are no longer updated, it might be outdated. There's also event logs. So if you remember from our other subject, we mentioned how DNS event logs were the logs of Windows operating systems. Okay, so let me quickly show you an example of this. So we can start the event log by going to Tools, Event Viewer, or we can right click on Start button and go to Event Viewer. It doesn't matter which way, but we know that there's some Windows logs. So there's some application logs, security logs, which actually logs whether people have succeeded or failed in accessing or connecting to your server or logging into your server or accessing resources from your server. There's the setup logs, which is to do with installation. There's the operating system logs. This is probably one of the ones that you will see more often. And you can see on mine, you have some white informational, white dots with an I in the middle. That's just informational. In this case, it's just saying something started, something stopped. It's not very important. It's not a big deal. It just gets logged. There's some yellow ones usually. They're warnings of something that might become a problem, but not really a problem. But it's the red ones you have to watch out for. In this case, there's an error. It's talking about local activation, and because this virtual machine is actually on the host-only network, it's never going to be able to connect to the internet to activate properly. Okay, so that's why that's an error there. But when we install server roles onto our servers, we actually get specific logs for that particular service, in this case DNS. Okay, so these are specific log entries or things or errors that's specifically to do with DNS server. And the great thing about DNS, these logs, is that you get what's called an event ID. 413, for example. If I've got 413 as the event ID, and I'm not sure about what the hell it's about, I can actually just open up my browser. I can go to technet.microsoft.com, for example. I can do a search for the event ID, and I could actually look at something that specifically fits my my event, and a lot of the time it will tell you what the problem is, see if it matches up, and it will actually give you steps and instructions on how to resolve the problem. So Microsoft TechNet is really great for using to help you troubleshoot or fix problems. It's a technical network between people who work with Microsoft products. So I use it all the time for problems I've never seen or can't fix myself. DNS has also got a debugging mode, which means that what debugging means is actually going to show to screen what is actually happening. Okay, so we can choose the level of information by actually turning debugging on or not, whether we look at the packets going out or coming in, whether it's UDP or TCP. So don't forget, UDP is what what's a DNS Queries uses, and TCP is what DNS Zone Transfers uses. So by basically displaying all this information to screen, we can actually see DNS working and help us work out what the problem is or fix it. And don't forget, anything you can do with the graphical user interface, you certainly can do with PowerShell. And there's a whole heap of commandlets that allows you to configure DNS, troubleshoot DNS, and change settings of DNS. All right, so that's the end of the PowerPoint. So I'm going to stop recording. And what I'll get you guys to do, so we've taken a little bit longer time than what probably I wanted. So what I want you guys to do now is to actually work through the worksheet 1. Okay? So hopefully you got the files now. So work through worksheet 1, and I will help you as you need help. Okay? So let me just look at where it's actually put my recording, and hopefully it's